we've discussed a few general motivations for human in the loop, like approval, like debugging, like editing. We've shown the first ones. We talked about how you can use breakpoints to stop the graph and approve certain actions like tool calls. But we don't yet know how to actually edit the graph state once it's stopped, which is really that third use case we talked about above. So let's discuss it here. We know we can use breakpoints. We know we can use them for human approval. But breakpoints also give us an opportunity to actually modify the graph state because the graph is stopped, and we can manipulate and grab the state as we want. So let's redefine our agent. Again, perform simple arithmetic. And now we're just going to add interrupt before assistant. So a very minor change relative to what we did before. So now you can see, same flow, except we'll interrupt before we actually run the assistant. Let's go ahead and run this. Create a new thread. Passive input multiply 2 and 3. And let's give this a shot. Now you can see nothing happens. We see the human message go in, but we've stopped before the assistant has an opportunity to do anything. Now what's kind of cool is, again like we showed, you can run graph.getState, pass in the thread, and you can get the state. So we can see here's a state snapshot. It only contains that human message input. Now here's where I want to show you something new. We can apply state update. So here, we're going to go ahead and pass a human message that says, no, actually multiply 3 and 3. There we go. All we called is graph.update state. Now let's just go ahead and look at the new state of the graph. Here we go. So there it is. Now we have 2 human messages. Remember, when we update the state, we pass in a message, it will use the existing reducer that's already defined for this particular key, messages in our graph. The messages key uses the add message reducer, which will append messages to this key or channel in our graph unless certain conditions are met. Like, for example, if the message ID is identical, it'll overwrite it. But in this case, I'm just going to append because I haven't passed a message ID here. So now we're passing in 2 human messages. Multiply 2 and 3. No, actually multiply 3 and 3. Now all we need to do is pass in none to proceed from our current state, which is supplied by this thread. Again, let's stream and see what happens. So there we go. This is correct then. The LLM sees this updated message, formulates a tool call that says multiply 3 and 3. We get the tool message output as 9. And now, actually, if we want to finish this, all we need to do is run this again because we've actually stopped again at the assistant node. If you recall, we've interrupted before assistant. So what's happened is we've gone, we've updated the human input, we've then gone to the tools node. Tools node has returned the tools output to the assistant, and we've stopped again. So now to finish this off, we invoke our graph one more time. There it is. You get the final AI message. Now let's briefly show how to do this in Studio. So you can say, I'll start off and I'll say multiply 2 and 3. Now recall, we have an interrupt before the tools node here. But what's kind of nice is, in Studio, I can also manually add interrupts at any point in my graph. So let's say I want to just add one here before the assistant node. So now we'll interrupt before the assistant node. And in code, I already specified a breakpoint before the tools node. So let's see what happens here. I run, and we've stopped. So let's just do what we did before. Here I'm just going to go to edit, and let's just say I'm going to change this to multiply 3 and 3. Now all I need to do is fork my thread because I've changed the state here. So I fork, and there we go. I've gone ahead. We still have that prior interrupt before running the tool node. But that's fine. We actually like this input. It looks correct. 3 and 3. We go ahead and continue to tools. We let the assistant run because the tool node has returned 9, which we believe to be correct. We'll keep that. Rerun the assistant node. And there we go. The result of multiplying 3 and 3 is 9. So it's very easy to manually add breakpoints in your graph in LangGraph Studio just by using this interrupt. So I've clearly seen how to edit graph state in Studio. Now let's go ahead and edit graph state via the LangGraph API. So recall the LangGraph API underpins Studio. We can interact the API directly via the LangGraph SDK. And all we need to do, of course, is just pass in the URL for our local Studio. We'll supply our assistant ID, we'll create a new thread, and we'll do the same as we did before. Let's add an interrupt before assistant, just like we did before. We'll pass in the same input, 2 and 3, and let's see what happens. Cool, so we've stopped, just like as expected, before we hit the assistant node, just as expected here. And again, just like we did before, we can get the current state. So there we go. We can look at the state. Again, it just contains this human message. And we can modify the state. So let's just grab that last message in our state. Here it is. This is that human message right here. And we can modify it. Say last message, content, no, multiply 3 and 3. Cool. So now we can look at that last message. There it is. So now it is no, actually multiply 3 and 3. Now again, we talked about this will just be applied as a state update given the messages reducer. But there's one interesting trick here that we've done. We've taken this existing message and only modified the content. We've kept the message ID consistent. So what's going to happen is when we update the state here, we're actually going to overwrite the value of the existing message because we've supplied a message ID. So let's run that. There it is. We updated state. Now let's try resuming. We'll go ahead and pass none, just like we did before. We'll stream the values and we'll look at what goes on. So we proceed with the tool call, and we get the result of the tool invocation. In this case, the tool returns 9, as expected. And to finish that off, we can just call it again. Input none, as mentioned before. And there it is. You get the final assistant invocation. The result of multiplying 3 by 3 is 9. Remember that we stopped here because we add this interrupt before assistant. So what happened is our assistant formulated the tool call. That went to the tools node. The tools node ran the tool call, returns 9 to our assistant. Then it stops again. And we go ahead and pick up where we left off here. We get the final answer. So we've shown you can create a breakpoint in your graph. You can edit the graph state at a given breakpoint. But I want to show a nice trick. What if we actually want to explicitly get user input to modify the state? So we can do that really easily by supplying what we're going to call a dummy node, which will basically be a no-op node, as we mentioned here, that will basically accept the user feedback and inject it into our graph at a particular point. So let me just lay this out and show it in detail here. So we're going to create that same agent we just talked about, but I'm going to add a little human feedback node before the assistant, okay? So before, remember we interrupted on the assistant, and then we just edited the graph state in the assistant node. Let's just add a node here prior to the assistant that will actually allow us to inject human feedback explicitly as if this node was running. So let's go ahead and define an initial input, multiply 2 and 3. We'll create a new thread. We'll run the graph until the first interruption, which we're going to expect to come at that human feedback node. Okay. Now here's where I'm going to add this input. Tell me how you want to update the state. This is going to be passed from the user. Now I'm going to call that graph.update state just like we showed before. But you see this as node? That will apply this update to state as if this human feedback node ran it. That's really it. It's super simple. So let's run that right now. So okay, here's the initial human message. Multiply 2 and 3. That goes as human feedback node. Let's say I want to modify that. So I say no, multiply 3 and 3. There it is. Cool. So the tool call is modified accordingly. There it is. The tool message is returned. So we've gone back to the human feedback node. There's no more feedback I actually want to add, so I don't need to update the state anymore. So I can just continue, basically. There we go. AI responds, and we're done. So this is a very nice way to systematically inject human feedback at specific points in your graph, to create what we call a dummy node that will interrupt before, and you'll basically add feedback as if that node is running. And you do that really simply with this update state, pass in your thread ID, pass in the state update you want, and just call as node human feedback. And that state update will be performed as if that node was doing it.